Okay, as promised, what I'd like to do is create a hopefully short video on blood typing, explaining what blood typing is, um, what we use in order to help type somebody's blood, and then what that actually means in terms of how we do medical care for these patients. So my kid is screaming in the background. Awesome timing, but it is what it is. Okay, so blood typing. What do you guys already know about blood typing? Most people have heard of the basic blood types. Okay, so when we're blood typing, what we want to be able to think about is type A blood. Yeah, we've seen that before probably. Type B blood, cool, and type O blood. Those are the three major blood types. By the way, part of what I'm going to ask you guys to do is, even if you don't know your own blood type, somebody in your family probably does. Okay, your mom probably knows your blood type, your dad probably knows your blood type, somebody probably knows your blood type. So I'm going to ask you guys to go and search for your blood type. I'd love for you guys to be able to share that. If you don't know your own blood type, maybe you've never been blood typed. It's possible. Then try to find out what your parents' blood types are. And by looking at your parents' blood types, you can often infer what your blood type might be. What is a blood type? What does that even mean? A blood type has to do with a particular identity marker, which is basically a protein and a carbohydrate put together that's hanging off of your cells of your body. Okay, so if we come over here and we start to draw, say for instance, a red blood cell, because that's ultimately what we're after here, if we put a little tag on this thing, okay, we put a little flag on it, and I like to draw flags, like actual flags. I don't know, it's more fun that way. That's a protein carbohydrate combo identity marker. This is called an antigen. Antigen, okay? Antigen. An antigen is an identity marker that identifies self. As long as the cells of your body have this flag, then your body will recognize it as self. As long as your body has this flag, then your body won't kill it. If your body comes across a cell with a different type of flag than your body is used to, it will try to kill it. If it comes a cell with no flag, it will try to kill it. So guess what these antigens are called? Those are our types. So there's an A antigen. Well, that A antigen, if you had the A antigen, you would have type A blood. Cool. There's another antigen called a B antigen. So now we got a B antigen. Sweet. What if you have the B antigen? Then you'd have type B blood. But what if you had both the type A and the type B antigens? Well, now what we're going to have is actually something called type AB blood. I didn't mention that in my original list. I apologize about that. So this is type AB blood. And then what if we had no antigens? That's what type O means. Type O is going to mean I do not have any antigens at all. So if I want to start writing a list or a table that helps me put this stuff into some sort of comprehensive study guide, then I can say type A, and let's put a column in here that says antigens present. Antigens present. So what antigens do we know found in type A? It's the A antigen. Don't just write A. Nothing irritates me more. Okay, don't just type A. Very frustrating when you guys do that. These are specifically A antigens. A is just a letter. So type B blood is going to have the B antigen. Type AB blood will have the A and B antigen. So in other words, A antigen and the B antigen. And type O doesn't have any. So we're going to write none or no antigens. Sweet. All right, cool. How does this identify as self? Well, what you have in your body that tries to run around and identify the different flags, well, that's your immune system. And more specifically, it's your lymphocytes of your immune system. And what the lymphocytes do is as they're running around and they're checking for flags, if they find a flag that shouldn't be there, let me say that again, if those lymphocytes find a flag that should not be there, then they are going to tag them. They're going to put a little label on them that says, this needs to die. What is that tag called? It's called an antibody. These are called antibodies. Just because it starts with the word anti doesn't mean it's the same thing as an antigen. In fact, it's very different. Antibodies are going to tell our body, tell our immune system to kill whatever has that antibody on it. It's a label, it's a tag. Okay, it's a tag or a label that tags for removal. It's going to tell a monocyte, for instance, to come and eat this particular piece of debris. This is a foreign object. It doesn't belong here. Let's eat it and get rid of it. So let's think about this. If you have an A antigen, do you want an antibody against the A antigen? No. If you had an antibody that flagged the A antigen for removal, wouldn't that just kill you? So you don't want what's called an anti-A. All right, so the different types of antibodies that we talk about for blood typing. Anti-A, that's not anti. Anti, by the way, in science, if we just write anti with a little slash after it, it always means antibody. It doesn't mean antigen, it doesn't mean any other anti. Anti always tells us antibody because antibodies are a part of our immune system and they're really important. So we say we have anti-A, anti-B. Those are the major two antibodies that we find in our body. Cool. Anti-A. Would we want anti-A if we were a type A blood? Again, that anti-A is going to be anti-A. So if it sees an A antigen, it's going to tag it and your body's going to kill it. You do not have an anti-A antibody if you are an A antigen blood type. That would kill you. So when you're born, you're going to have what's called preformed antibodies. This is your body's natural ability to produce antibodies against foreign objects. They're passed on from mama, good old mama bear. What preformed antibodies are going to be present in a type A blood person? Not an anti-A, they are going to have an anti-B. This is important because now if somebody were to be a type A blood and they get something in their blood that has the B antigen on it, your body now recognizes that as foreign. Therefore, it's going to tag it with an antibody against that B antigen, and your body's going to try to kill it. So you always have the preformed antibody that's opposite of your antigen. So what if you're a type B blood? Can't have that anti-B, it'll kill you. Therefore, you will have the anti-A. Well, what if you're a type AB? Well, then you have an A antigen and a B antigen. Can you have the anti-A? Nope, that would kill you. Can you have the anti-B? Nope, that would kill you. So what preformed antibodies do you have? None. Your body has other means of getting rid of foreign objects. Versus if you're a type O blood, you don't have the A antigen, you don't have the B antigen, therefore you would have both an anti-A and an anti-B. you would end up with both of those preformed antibodies to fight against A antigens or B antigens that got into your bloodstream. What if you're a type A blood? Can you be given a type B blood? When you're given a type B blood, by the way, the antibodies stay behind. We don't worry about those when you are receiving blood from another person. However, you're a type A blood receiving a B antigen. Uh-oh. What does your body have antibodies against? That B antigen. So your body is going to start to flag those B antigens for removal, and this is going to end up causing you to become very, very sick, if not very, very dead. Does that make sense? I hope so. Okay, that anti-B will start to bind with that B antigen. Bad stuff happens. Why is that? Because antibodies are proteins. Okay, these are Y-shaped proteins. That's kind of important to this whole thing. Okay, they're Y-shaped proteins. That's important because if I have an antibody that is Y-shaped and it recognizes an antigen found on a cell, well, it's going to bind that cell up. But then look, it's got two other ends. And all ends of this Y-shaped protein are very, very sticky. They're all going to bind. So check it out. Now I have another cell with that antigen that this antibody is against. It sticks there. Now I have another cell with that antigen. Well, is that the end of the story? Nope. Because this cell here got tagged with an antibody. This cell here got tagged with another antibody. This cell here got tagged with another antibody. Uh-oh. Uh-oh. Now we're going to start to create this big, huge, sticky mess of cells, right? And then these are going to have antibodies, and they just keep getting bigger and bigger and bigger. Okay, this clumping of cells is called agglutination. Very specific name to this. It's called agglutination. Okay, this shaping that's happening here is called agglutination. That is what you guys need to know this word as. Agglutination. This is not clotting. It's not what this is. This is called agglutination. So now look, why is this going to kill you? If you're a type A blood and you get type B blood, that type B blood has a B antigen. Your body starts to tag it for removal by tagging it with antibodies against the B. That's going to start to cause your blood to agglutinate. And when your blood agglutinates, all of these red blood cells start to stick together, clump together. These can no longer make it through the capillary beds of your body. And that's going to start to prevent oxygen exchange, and it's going to start to block up those capillary beds. No oxygen, no CO2 exchange, and that ends up killing tissues and ends up, well, killing people. Next idea. You may or may not have noticed that I haven't put in other types of blood types because there is A positive, A negative, B positive, AB positive. You guys get the point. So what do those positives and negatives mean? Those positive and negatives are referring to another antigen called anti-D. It's very, sorry, not anti-D, sorry, called antigen D, or the D antigen. Now here's the deal with the D antigen. We're going to draw it in actually with a different shape, just so you guys don't think of it as a typical antigen. It's not a typical antigen. This is the D antigen, also known as the Rh factor. Because it was originally found in rhesus monkeys, not because we got this blood from rhesus monkeys. The D antigen. Here's the deal with the D antigen, is when you are born, you do not have preformed antibodies against the D antigen. You don't have preformed antibodies. You don't get those antibodies passed down from mama bear, okay? Instead, your body has to build its own immunity against the D antigen if you don't already have it. So if you don't have the D antigen and you're exposed to the D antigen, your body has to start to build up an immune system against it. It doesn't immediately recognize it as foreign and just start to attack it and kill it. It's going to build an immune response. What is that immune response? It's going to start to produce antibodies against Rh. Okay, so I guess I should say, if exposed, these words are kind of used in the lab report, that's why I used it, to Rh positive blood, will this produce an immune response? Will antibodies be formed? Antibodies against Rh. So let's go over here and let's start to define different types of blood types, because we haven't really done that yet, right? So if I had type A, what about A negative? Okay, we can have an A negative, or actually, it doesn't matter, and A positive. A negative, B negative and a B positive. AB negative and an AB positive, and then finally we have O negative and an O positive. Okay, the antigens are going to be the same for all A types. The antigens will be the same for all B types, so forth, so on. Well, what differs now is whether you have a negative or positive Rh factor. If you're a negative for an Rh factor, that means you do not have the D antigen. Therefore, if you were exposed to the D antigen, would your body recognize it as foreign? The answer is yes. If you don't have the D antigen, then your body's not going to like seeing it, right? Your body is not ready for it. So if you're an A negative, if you're exposed to an Rh positive blood, that's going to start to produce an antibody against D. So this is going to start to produce anti-D. Yes. What if you're an A positive? Then the answer is no. Right? If you already have the D antigen and then you're exposed to the D antigen, you're not going to start to produce antibodies against it, because that would kill you. You don't want to recognize yourself as being foreign. What if you're a B negative blood? Are you going to get an antibody? Yes. What if you're a B positive blood? No. What about AB negative? Yes. You guys get the point here, and no. And then an O negative would be yes. And an O positive would be no, right? Your body is not going to start to produce antibodies against it if it's already present. So now we got to be real careful, because what if you are an A negative blood? Can you receive a blood type from A positive? The answer is no. If you receive a blood transfusion from an A positive, then that A positive is going to be bringing the Rh factor with it. Your body, as an A negative, does not recognize that D antigen as self. And so your body is going to start to form anti-D. The first time you're exposed to that A positive blood, it won't kill you. But now you have the anti-D built up in your body. So the second time you're exposed to that blood type, agglutination. Let's go the other way. What if you're an A positive blood? Can you receive blood from the A negative? Yes. You have the D antigen. The A negative blood does not. So that A negative blood enters your blood, and you're going to go, everything looks kosher. Okay, it doesn't have any antigens that I don't have, so we're good. So negatives can donate to the positive. Positives can't donate to the negative. Same thing would go here. B negative can donate to a B positive, but a B positive cannot donate to a B negative. AB negative can donate to an AB positive, but not the other way. And O negative can donate to O positive, but not the other way. Let's broaden our horizons. Let's look at blood types. across the board and whether they can donate to one another or not. Look at, we already talked about this. Can A ever donate to B? Nah. Can B ever donate to A? Nah. Can AB donate to B? Nope. Why not? Because an AB also has an A. Therefore, if you're a B blood type, it'll recognize the A side of this and say, crap, that's foreign, I gotta kill it, right? It's got an anti-A in it. Can't put A in there. However, can a B be donated to an AB? Yep, because the B, well, it doesn't come along with an A or whatever, but even if it did, it'd be fine, right? The type AB has the B antigen, so it can receive it. What about a B positive going into an AB negative, though? Ooh, now we got issues, right? Because the RH factor is opposite. If you give an AB negative a B positive, then that AB negative is going to react to that D antigen. Therefore, it's going to start to get antibodies against anti-D. The second time you expose it, they will agglutinate real bad, and that person will die. What about an O? Can A give to an O? Nope. It's got an antibody against A. Can B give to an O? Nope. Can AB give to an O? Nope. Oh, man. Poor O's. Can O give to an AB? Sure, because there's no antigen here. Even when there one, it wouldn't matter, right? So O's can give to AB. O, can they give to a B? Yep. O, can it give to an A? Yep. Why? Because there's no antigen. So how the heck is this thing going to recognize whether it's foreign or not? Let's go even further. What about an O negative? If it's O, there's no antigen against A. There's no antigen for B. If it's negative, there's no antigen for RH. In other words, there's no antigens whatsoever here. None whatsoever. Therefore, an O negative can be given to any blood type because no blood type will recognize it as foreign. There's no antigens for it to recognize as foreign. This is called a universal donor. Universal donor. O negative is the #1 sought after blood type on the face of the planet. If you are O negative, Red Cross will call you every single day. They want your blood. They want to suck your blood. It's relatively rare. Okay, it's the second most rare of the blood types. The most rare blood type is AB negative. By the way, the most common blood type is O positive. Probably about 60% of the world population is O positive. This is by far the most common blood type. Here's the deal with O positive blood, though. You can only receive positive or O negative blood. You can receive blood from anybody else, but that's okay because 60% of the world matches you. So tend not to have any trouble finding O positive blood to get into an O positive patient. But things start to get kind of complex. So for instance, for an AB negative person, this is by far the most rare. This is, I don't know, like, I don't know what the percentage, less than 1% of the world's population, by far, way less than 1% is AB negative. So now if you're AB negative, what blood types can you receive? You can receive an A negative. You cannot receive an A positive. You can receive a B negative. You cannot receive a B positive. You cannot receive an AB positive. You can receive an O negative, but you cannot receive an O positive. So you start to limit the different types of bloods that you can receive. Let's do this one, AB positive. What can an AB positive receive? Can it receive an A negative? Yep, it already has the A antigen and there's no RH factor, so we don't have to worry about that. Can it receive an A positive? Yep, it already has the A antigen and it already has the RH factor. Can it receive B negative? Yes. Can it receive B positive? Yes. Can it receive AB negative? Yes. Can it receive O negative? Yes. Can it receive O positive? Yes. AB positive is known as the universal acceptor. If you guys can understand these two concepts between universal donor and universal acceptor, you are going to be good to go in understanding how blood typing works and why we care about it. We really care about it due to the history of blood transfusions. Like, you know, back in the Civil War is kind of when the Red Cross started up, and you know, people were losing limbs. Fun, you know, musket bullets just ripping limbs basically off, cannonballs. People weren't dying, but they were losing limbs, and then they die because they lost their blood. So what the surgeons did would they freaking cut the arms and the legs off, and they do blood transfusions. Yeah, they do blood transfusions with a person dying next to them on a table. So that person's going to die anyways. They don't need their blood. So let's take their blood and drain it into this patient next to them. That's how blood transfusion started. Well, one of the main places, I guess I should say, where they were utilized in great abundance. And that's where they started collecting data. Like, this patient was able to properly transfuse, right? They got that blood transfusion and they didn't die. But that patient, even though they got their blood transfusion, they died. What the heck's going on? Well, it turned out that they were giving blood types, the wrong blood types to people, right? Because they weren't measuring blood types back in those days. Crazy. And then through the history from then on, Red Cross has been one of the leading people in looking at different blood types. Now, by the way, this is not the only type of blood typing capability out there. There's lots of different blood typing that exists. This is just one of the many types of ways to blood type, which blows my mind. It's too much for me to be able to learn right now, too. So now when we go to the lab report itself, what you're going to do is you'll come in here in the very first question, number 1 here, fill in the information for each blood type. So what do you know about O positive, A negative, B positive, AB negative? What antigens, what preformed, and are you going to start to produce an anti-RH? Sweet, I already did all that for you. Fill it in. Up here above, your blood type, you're not going to be able to do your hematocrit if you're part of the COVID people. If you are not COVID, then you'll be able to do this, no problem. But up here, I want you to fill out your blood type, especially if you're doing the lab, because future classes are going to use this recording as well. But if you're in the COVID class, then you can't do your own. So please call your relatives, reach out. You don't know your relatives, that's okay. That's okay. You can still just say, I don't know. Something along those lines. Try, because it's fun. Over here, it's really important to be able to think about these positives and negatives in relationship to mothers carrying babies. Ooh. If anybody is a mother listening to this recording and you have a negative blood type, you probably know it because you probably had to receive an injection of what's called RhoGAM. RhoGAM is basically something to be able to block Rh antibodies from forming. So let's think about that real quick. If you are a mama bear, or a mama human, of course. I like to say mama bears because mama bears are awesome. If you are a mama bear, you're passing on your blood type to your offspring. Papa bear over here, and we're going to go mama bear and papa bear, right? Papa bear over here, he's passing his blood type off to his offspring as well. And here's the thing with blood types is blood types are dominant genes. In other words, I guess I shouldn't say just any blood type. The D antigen is a dominant gene. So if one of your parents has the D antigen, then the offspring will have the D antigen. Doesn't matter if mom is negative and dad positive, what do you know the offspring is going to have? It's going to have a positive type blood. Okay? If mom's negative and dad's negative, offspring will have a negative type blood. If mom's positive and dad's negative, positive, 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 positive. So there's quite a few different ways to end up with positive blood. So if mom is carrying a positive baby, doesn't matter whether she's A negative, B negative, AB negative, O negative, right? If she's negative and she's carrying a positive baby, let's look at these negatives. If a person with negative is exposed to the Rh factor, what are they going to start to produce? Antibodies against that Rh factor. Mom is carrying a baby that has Rh. Do you want to start producing antibodies against that baby? I hope the answer is no. And it's one of the #1 reasons for miscarriages through thousands of years, right? Because mama bear has a baby. Sure, she has her first baby. Okay, first baby comes out. First baby is a positive type blood. Through that whole time, mom has been giving baby everything that that baby needs, nutrients and all that sort of stuff. And it's mom's blood that is now circulating through that baby. We don't need to worry about this baby, because this baby right here, well, its antibodies haven't really been mixing with mom, or its antigens, I guess I should say. So the mom's really not producing a lot of antibodies against this baby yet. But childbirth is not bloodless. It's an extremely bloody affair. Moms know that. And blood can get exchanged. And when that happens, moms will start to produce antibodies against the D antigen. And so the second baby that they become pregnant with, same dad, positive type kid, mom's body attacks it and kills it. Pretty crazy cycle of events. There's lots of things online that you guys can read about that. If that didn't make perfect sense, I understand. I didn't do it justice because I'm trying to get through this particular lecture for you. But what I want you guys to think about here is, if we got a positive mom, a negative fetus, do we need to worry about anything? If you have a negative mom with a positive fetus, do we need to worry about anything? And if both are negative, do we need to worry about anything? So I want you guys to think this out, draw it out. Ask yourself when antibodies are created, or if the antibodies even are created. All right, last bit of this lecture. I know, guys, I'm trying to go fast. There's just lots of learning to be done here. Is how can we use this to blood type? How can we use this knowledge to create a test that will help us blood type a patient? And the answer is those antibodies cause agglutination. And so what we, not me, a guy named Eldon, smart little scientist that he was, Eldon created a card. And this card is just a big rectangular card. On this card, he basically just has 4 little circles on here, 1, 2, 3, and 4. Each circle is not bigger than the last. I just suck at drawing. Okay, these were all supposed to be the same size circles, whatever. And in each one of these circles, Eldon has placed synthetic antibodies. Okay, inside of this circle, there'd be a little circle of kind of looks like a little eyeball. Anyways, a little circle of anti-A. Inside of the next circle, there'll be a little circle of anti-B. Inside of the next circle, there'll be a little circle of, these aren't the right colors in terms of, I don't remember what the colors on the cards actually are when I did this video here, so whatever. This is going to be anti-D. And the last one is called a control. So there's no antibodies whatsoever here, control. So there'll be just a little dot of colored, basically dyed water, but it's a control. There's no antibodies. So now let's think about using the control first and foremost. If you put a blood onto the control, if there's no antibodies there, then those antibodies will not recognize any antigens. Why is that important? What do antibodies do when they recognize antigens? They will agglutinate. So if I have a control with no antibodies, then no agglutination will ever occur. I love that. Controls are important in our understanding. Controls cannot have agglutination. Why? Because there's no antibody to recognize an antigen. So let's start putting blood types on here and see what happens. Remember what I said about a blood type. So say, for instance, let's go with an A positive blood type. A positive. What antigens does an A positive blood type have? This is going to have the A antigen, and it will have the D antigen. Doesn't it have both of those? It's an A positive blood type, so it has an A antigen and a D antigen. So if I put an A antigen onto an anti-A, will it agglutinate? You better believe it, right? So what would I see on this card? When I looked at this card, A agglutinates. And what that means is it actually ends up causing a cluster of cells. It causes this clumping effect of those cells with the anti-A. What about B? There's no B antigen anywhere in here, so there's no agglutination when we look at this anti-B. It's just going to be clear. There's no clumping whatsoever. It's just a clear liquid. What about anti-D? Well, we have the D antigen on an A positive person, therefore we would have agglutination. They're going to clump together. And then, of course, on control, what did we say up here? What's so cool about controls is they are just that. They're a control. So no agglutination is possible. Just a way to be able to determine, does something agglutinate or so does something not. So when we look at the card for an A positive person, it agglutinates on the antigens, or I guess I should say it agglutinates on the antibodies for the antigens that's present in the blood. One part that students really have trouble with is they're like, wait a minute, an A blood type can't have anti-A. You're correct, but an Eldon card is not your body. This is a artificial situation. This is a laboratory situation where we put antibody on a card, and then we put your blood on that antibody. Therefore, if you have the antigen, it will agglutinate. It's that simple. It's a really, really simple idea. If you have the antigen, then agglutination occurs. Huh. All right, what about a B negative? Do we get agglutination on anti-A? Nope. Do we get agglutination on anti-B? Yep. Go ahead and put nope and yep, because why not? What about on the anti-D? Well, I'm a negative type, so there's no agglutination. And then, of course, there's no agglutination ever on our control. Forgot to write control up here. Does that make sense? What if we are an AB positive? Then I got a yep, 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 and a nope. Right? If you have that blood type, then you would have that agglutination. Let me repeat that. If you have the blood type, then you have the antigen. If you have the antigen, then agglutination occurs. Let's look this real quick. Don't mind this, just an exam. Leave that. But let's go ahead and say Eldon card on the internet, right? And you can look up images for those Eldon card tests, and you can actually see, hey, here's a great example. So I'm going to go ahead and open that image in a new tab. Ah, tiny, but that's okay. Look, I'm an O positive blood. What antigen do I have? If I'm O positive, I only have the D antigen. So as I go across on the card, where is there agglutination? Oh my gosh, it's on the anti-D because it recognized my D antigen and caused agglutination. Nowhere else. O negative, there's no antigens, therefore no agglutination. O A positive, I have an A antigen, so it agglutinates on the anti-A, and I have a D antigen, so it agglutinates on the anti-D. You guys get the point, right? Welcome to blood typing. I don't know why I just did a Dracula voice. Vampires. So now you guys can finish out the rest of your lab reports. Subject 1, Subject 2, Subject 3, Subject 4. You look at their cards. I have agglutination, 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 agglutination on anti-A, anti-B, anti-D. What blood type does this person have? If it agglutinates, you have the blood type. So this person would have blah, blah, blah. I'm not going to say it out loud because it's graded. You guys get the point, I hope. All right, that is all. I'm excited. I've been meaning to do this for years. So this should help out lots of students, not just in fall 2020, but everywhere, every time. Humankind, be both. Be nice to yourself. Be nice to your neighbors. Peace.